Good afternoon, students. After completing the elementary operation, now here let's take some examples here. So here these examples are actually from the miscellaneous part, and this one is example number 26. Actually this question is very important examination point of view. So now in this question what you have to do here, let's say, so a matrix given to you, a cos theta sin theta minus sin theta cos theta given to you, and now here what we need to prove, a to the power n equal to cos n theta sin n theta minus sin n theta and cos n theta, where n is what? A natural number. So that means here n term given to you, and here the main matrix is given here, this one. Now let's see here the proof. So if this type of n terms of questions are given to you in class 11, already we proved this type of questions. N is the natural number, so that's why we have to apply here the principle of mathematical induction, which one in short is we say PMI. So first of all what you have to do, with the help of principle of mathematical induction, we have to do this one. So for this mainly 3 steps are there, already we know. First step, we need to prove n equal to 1. Second step, we assume n equal to k, and the third step we need to prove n equal to k plus 1. So when we consider this statement is Pn, so that's why Pn, the statement we have to consider this one. This statement we have to consider as Pn. So now here if you put n equal to 1, so that means in this statement in place of n you have to put 1, so a, and similarly here in place of n you have to put 1, so cos theta sin theta. Ultimately this result is what? The main matrix or not. So when you put n equal to 1, then you get this main matrix. So that means from here what we can say, the statement is true for n equal to 1. So next step is we assume n equal to k, where k is lies between 1 and n. So in place of n we put k, so that's why the matrix is this one. So in place of n if you put k, then the statement is this one we get. Actually this one is a matrix and this one is the main one. So here a to the power k cos k theta sin k theta minus sin k theta cos k theta we get here. This one is in terms of k. Now the third step is we need to prove the result is true for n equal to k plus 1. So how can you write n equal to k plus 1? So the left hand side, from the left hand side we can prove this. So in place of n we write k, so that's why we have to write k plus 1. You see, in place of n we need to prove k plus 1. So here in the left hand side a, and in place of n we write k plus 1. So if you separate this one, a into a to the power k, so a matrix already given and k matrix whatever we assume we put these two, and then we have to multiply these two. After multiplying, this one is the formula of cos a cos b minus sin a sin b, that means cos a plus b. Similarly the other formulas we write here, and from here the result we get in terms of n. In place of n if you put k plus 1, the same result we get, which one we get here. So from here what we can say, the statement is true for n equal to k plus 1. So in this way we can prove. So finally we have to write, hence the statement is true for all n belongs to n. Is it clear? Okay. Next, another example, if you see here example 28 from page number 99 here. So here 3 matrices are given, A, B, C, and here we have to find out the fourth matrix D. And for this one condition is given, CD minus AB equal to 0. 0 means here 0 matrix. So now in this case what you have to do, first of all you see here CD. So first of all we consider the D matrix. So D matrix we consider ABCD. You can consider XYZ or whatever you consider. So we just consider a matrix of order 2 by 2. Reason behind, so here all other matrices are 2 by 2. So that's why D matrix we consider here 2 by 2. And now here, okay, now here you see the condition is given CD minus AB. So CD, C we have to write down the matrix whatever given, D we assume, so that's why we have to put this, and then we put AB equal to 0. 0 means 0 matrix. So after multiplying these two and subtracting, we get this type of result here. Okay, now here you see the order is 2 by 2, again here the order is 2 by 2, so easily we can compare. So we get 4 results here. So if you see the first equation twice a plus 5c minus 3 equal to 0 we get. Second one is we get here 3a plus 8c minus 43 we get. So if you solve these two by any one method, either substitution, elimination or cross multiplication, if any one method, if you apply these two, then easily you get the value of a and c, and the a value is minus 191 you get, and c equal to 77 we get here. And after getting these two, similarly if you solve b, the third and fourth, then you get the value of b and d. So after getting this a, b, c, d value, you have to put here, and then we get the required answer. Is it clear? Okay. Now from the miscellaneous part on chapter number 3, let's see the first question here. The first question is this one, and the question is here what? The matrix given to you and the statement is given this one. So this result in given in terms of n. So obviously we know one example already we have done. With the help of PMI we have to solve this one. So first of all, this one, what you have to do, we have to put n equal to 1 to assume this one. So on the left hand side as well as on the right hand side, you have to put this n equal to 1, and let's see what you get. If both the results are same, then you can say P1 is true, and then after that you have to assume n equal to k. So that means when you put n equal to k, so pk equal to, here in place of n you have to put k, and here all in n, in place of n we have to put k, and then you put this one is equation number 2. And after that what you have to do, we have to prove the statement is true for n equal to k plus 1. So in k plus 1, what you have to do, just you have to take this left hand side. So ai plus ba holding to power n is there, so in place of n we have to put k plus 1. So if you put k plus 1 by the property of indices, so easily we can separate these two. All of you understood this one. So ai plus ba and ai plus ba holding to power k, easily we can separate because here power is k plus 1. And now after that ai plus ba, since when we put n equal to k, then in place of this n and in place of this n we can put k. So this result we have to put here, ai plus ba to the power k. That means this result we have to put here from this equation 2. And then after that we have to multiply these two. Then if you multiply these two, ai we have to multiply these two terms, similarly ba we have to multiply these two terms, total 4 terms we get. Now in this place, if you see ba, if you multiply this one, this whole part, then a into a square you get. So let's see what is the value of a square. So a square means we can write a dot a. So if you multiply a dot a, then we get the result is what? 0 matrix. So that means when we multiply ba with this result, then the result we get 0 matrix. So that means here only 3 terms remain. So the first term we write this one, and the other two if you take common, then you get this type of result. So this result is same as the nth term result. So that's why from here what we can say, the statement is true for n equal to k plus 1. So the statement is true for all n belongs to n. So in this way we can prove this result. Is it clear? So similarly another 2 questions are given in your miscellaneous, question number 2 and question number 3. In the same way, with the help of PMI you have to prove these two. Is it clear? Okay. Now after 2 and 3, the next question is given in miscellaneous, a and b are symmetric matrices. So here we need to prove ab minus ba is skew symmetric. So first of all, the condition is given a and b are symmetric matrices. So the condition of a and b are symmetric matrices are here written. You see a transpose equal to a and b transpose equal to b. Actually these two are the condition of symmetric matrices. So now we need to prove skew symmetric matrices. So now here whatever the result given ab minus ba, so this result we have to consider, we have to assume d as a matrix. So what is the condition of skew symmetric matrices? The skew symmetric matrices condition is this one, d transpose equal to minus d. So that means this result, whatever we consider d here, this result we need to prove this type of form. So now here what you have to do, first of all we have to transpose this result. So when we transpose, whole transpose we write, since we know a property a minus b transpose means we can write a transpose minus b transpose, isn't it? So that's why with the help of this property we separate these two. And now here one more property we know, ab transpose means ba transpose a transpose. Similarly ba transpose means a transpose b transpose. Is it clear? So we write these two. Now after that, here B transpose and A transpose. The value of B transpose and A transpose already we know. So these two value we have to put here, BA, and here we have to write AB. And now if you take minus common, then AB minus BA remain. So AB minus BA means what? We assume D. So that's why D transpose equal to we have to write minus D. So we satisfy our skew symmetric condition. So that's why finally the conclusion we have to write, hence AB minus BA is a skew symmetric matrix. Is it clear? Okay. After question number 4, next question is here given B transpose AB. If you see the question number 5, B transpose AB is symmetric or skew symmetric. That means the meaning is what here? B transpose AB is symmetric if this A matrix is symmetric. And similarly, B transpose AB is skew symmetric if A is what? Skew symmetric. So that means how can you prove this result you see here? So that means symmetric condition is A transpose A. So how can we prove this result? So first of all we have to write, if A is symmetric, then we get this A transpose equal to A. Is it clear? Now after that what we have to do here, so this B transpose AB, this whole result we have to do transpose, or you can assume C also. Is it clear? So you have to assume C and then we have to put this one is transpose. Now from this C transpose we need the result C. So how can you do this one? So first of all here, if two results are given, A, B transpose, then easily we can write B transpose, A transpose. But here three matrices are given. So how can we write? First of all, we assume, AB as a one matrix. AB as a one matrix and B transpose is another one. So if you do whole transpose, B transpose, AB whole transpose, then the result we have to write, if you assume AB as a one matrix, then you have to write AB transpose into B transpose whole transpose. And then again in place of AB you have to apply the B transpose A transpose condition. So in this way you have to transpose there, and after transposing, in place of A transpose you have to put A. Is it clear? In place of A transpose you have to put A, and then let's see the whole result you get, again same result you get here. So in this way you can prove the symmetric. Similarly in case of skew symmetric you have to do transpose, and the same condition, same thing we have to do here, but in place of A transpose what you have to put? Minus A we have to put. And then if you get the result in terms of minus, because the skew symmetric condition is what? A transpose equal to minus A. So that means if you get this condition, then our proof is here complete. Is it clear? Okay. Next, if you see the question number 6, a matrix given to you, and the matrix is given like in this way. This one is the matrix given, and with respect to this one condition is also given, A transpose into A equal to I. So here I is the identity matrix, A transpose. So transpose means all of you know, interchanging of row and columns. So here I identity matrix totally depending on the given matrix. The order of the given matrix is what? 3 by 3. So that's why we have to assume the identity matrix as 3 by 3. Now first of all you see here A matrix given. So first of all you have to find out the A transpose. So A transpose result is this one. After finding the A transpose result, now here whatever the condition given here you have to write A transpose A equal to I. So in place of A transpose you have to put this result. Here you see we put this result, and in place of A we put this result. And I means the identity matrix we have to write of 3 by 3 order. So now after that you have to multiply these two. So all of you know how to multiply this. First row, first column. First row, second column. First row, third column. So we multiply this. So here only for the first row we write here the 3 results equal to the identity matrix of order 3. Similarly in case of Y, the second row, first column, second row, second column, second row, third column we have to multiply here. Similarly for the third row we have to multiply. And after that you see here the first row, first column element is this one. So this element we can compare with the first row, first column element of this matrix. So this first row first column element is equal to 1, so which one we compare here, and from here we get the value of x. Similarly, you can compare other results and find out the value of y and z from here. Is it clear? Very simple question, easily you can solve this one. Okay, so in this way you can solve the question number 7, 8, 9, 11 and 12 is also we use here the induction method, so easily, or 10 also we can solve here very easily. So now here these are the questions here from the miscellaneous part. So now from the 13, 14, 15 are the MCQ questions. So here one question is here, the question number 10. So in your miscellaneous part, if you see the question number 10, so the market price, two market price are given. Just you have to construct the matrix by your own. Is it clear? After constructing, easily you can find out the result. So if you face any problem in question number 10, remember in question number 10, so you can ask me. So now let's see here the MCQ questions. So in question number 13, first of all, in question number 13 the matrix is given this one, and here one condition is given, a square equal to I. A square means we can write a into a. So a into a means we can put these two matrix and then we have to multiply these two results, first row first column, first row second column. So after multiplying the result we have to compare with this matrix. If you compare, then any one option you find out from this four, so which one is our required answer. So in this way you can solve this question number 13. So in question number 14, matrix is given and the matrix is both symmetric and skew symmetric, and here four options are given. Diagonal matrix 0, A is a 0 matrix, A is a square matrix, none of this. So here A is a symmetric given, so that's why this condition satisfied here, A transpose equal to A. Similarly, A is skew symmetric, that means A transpose equal to minus A given. We know. So if you multiply 1 minus on both sides, then minus A transpose equal to A you get. So this equation and this equation, these two equations you have to add. If you add the right hand side A plus A, we can write twice A, and in the left hand side A transpose minus A transpose we write. Ultimately this one is 0, so twice A or A equal to 0. If A equal to 0, then what you can say? A is a 0 matrix. Is it clear? So in this way you can complete the question number 15 also. Is it clear? So now here our matrix part is over here. So your task is from the exercise I think 3.1 up to 3.4, including the miscellaneous exercise also 3.5, you have to complete properly. Is it clear? This part is very important and this chapter is very easy actually. In our next class we start the next part here, determinants. So actually the matrix chapter is not over here. After discussing the determinant parts, again we continue the matrix part. Is it clear? So I hope all of you understood this matrix part, and especially you have to practice the elementary operation. How can we find out the inverse? So this one is very important question here. Is it clear? Okay, thank you.